Here is an explanation for the answer to final exam question number 90 in Alternative Energy Demystified, 2nd edition. If you have the printed book, please see page 330. We're talking here about a hydroelectric power plant or power system, power generating system, that uses two or more reservoirs with water levels at different elevations. The difference in that elevation provides the energy to get the electricity out of the water when it flows from the upper reservoir or reservoirs to the lower reservoir or reservoirs through a penstock, through a water turbine, and we'll look at a diagram of that in a minute. But what kind of a system actually uses this principle? Well, the giveaway is what happens when the reservoirs attain equal potential energies and you can't get any energy out of them anymore. These are reservoirs. These are not oceans or rivers where water keeps coming and coming and coming. These are reservoirs that are like closed tubs, closed systems in and of themselves, and when they all attain the same level of potential energy in terms of the water that they're storing, you can't get any more out of them by letting water flow from one to another because there's no difference anymore. So you need to have a pump, and you need to pump some energy back into that system by raising the level of one or more of the reservoirs above the other one or other ones so that you can once again let water flow from the higher to the lower elevation. So the correct answer here is C, a pumped storage type hydroelectric power plant. And another key word besides pumped is the word storage, and we'll see why that is right now. So let's look at a diagram of this type of a system. What we have here is an upper reservoir and a lower reservoir, and water flowing from the upper one to the lower one through a penstock and a water turbine to generate electricity. Well, energy is stored in this upper reservoir until it runs out. Then there's no more. We need to use a pump to pump water back in and store it again. Well, where does the energy from that pump come from? It's obviously not going to come from this system when the reservoirs are already at their 0 point. So this type of a system stores the electrical energy for use when it is needed. But when it runs out, you've got to supply some external energy to get the energy stored back into it again. So in that case, it is in fact something like a huge battery or a fuel cell or the hydroelectric equivalent of something like that. Supercapacitor, a hydroelectric supercapacitor if these reservoirs are big enough. But you don't get something for nothing here. You don't get energy from the ocean or from a river and just keep getting it. You have to give in order to get. So this is nothing more really than a backup system for use when energy is needed, but it's not going to be continuously available. In fact, it's even less continuously available than sunshine or wind power in the sense that you have to give back this potential energy some way when it runs out. In order to do that, you need to get energy from somewhere else. So that, anyway, is the correct answer to this question, is choice C. A pumped storage hydroelectric power plant works like this.